Okay, so we're going to start a new chapter, chapter 3, and the title of this chapter is called Stoichiometry. Where does this come from, this name Stoichiometry? I think it's, actually it might be Greek. I don't really know the history of the word, but it has to come from the word prefix stoichion, which is a measure, and it's about measuring quantities in chemistry. So like how many atoms are in this picture right now, or in all these pictures, or in this one that I'm just kind of circling. This is mercury here, this is copper atoms, this is iron nails, this is sulfur, this is carbon. How many atoms are in each one of these? We'll get to it later, but they actually have an equal number of atoms, of copper atoms as there are sulfur atoms and mercury, iron, and carbon in this picture. And how do we know that? Did someone go in and count them? No, but there's a way we measure the stuff, and this topic is called, and the stuff that way we measure the stuff, it's called stoichiometry. Okay, so let's get started with this stuff. In stoichiometry, I'm trying to click to the next slide. There we go. Okay. We're going to try to get to the small world of atoms and molecules, also known as just the micro world. Micro just meaning small. Small world of atoms and molecules to our larger scale, our macro world, where we measure things in grams. In our scale, we measure things in grams, like we measure things in, say, meters in our normal scale for length. But for atoms, we don't use meters. That's just way too big. For atoms in this really tiny scale, we have to actually come up with a new scale system. A new scale system for measuring the size of atoms. Why do we use a new scale system for measuring atoms? Well, atoms are really, really, really tiny. You can't just measure atoms in grams. Well, I can tell you it'll be 0.0000, I don't even know how many, but many, many zeros, around I think 22 zeros. Is the weight in grams is the weight of one atom in general. So instead of using that, we come up with another unit, and the unit that we use is called the atomic mass unit. Atomic mass is the mass of an atom in atomic mass units. It's kind of like saying the distance between here and the next galaxy. We don't use meters. Meters are too tiny to talk about the distance between our galaxy and the next galaxy. We use another scale that you probably already know, light years. The reason why we use another scale for distance in space, things are really, really far apart. So we don't use our normal scales. So the scale that we use in chemistry for really tiny things, atoms, is atomic mass. So it comes to like, okay, well, what is the definition of atomic mass unit? Like, what's the definition of light year? You probably already know. Is it, well, if you didn't know, the definition of light year is the distance light travels in a year, which I don't know what that is offhand, but is a really, really far distance. What is an atomic mass unit? I don't know. It's just something we made up. It's kind of like, for instance, what in the world is a kilogram? If you think about what is a kilogram, which is our SI unit of weight or mass, just so you know, it's about the weight of a liter of water. So a liter of water weighs about a kilogram. Why do we use water? Because it's just a very common substance. I don't even want to get into the definition of what is a liter. Let's not go into that right now. But a kilogram is a weight of approximately a liter of water. So what is an atomic mass unit? It's something we made up. And the definition is this. By definition, one carbon-12 atom weighs 12 AMUs. Why do we come up with that? Carbon-12 is the most common form of carbon. There's many different isotopes of carbon, but carbon-12 is the most common form. So we just use the most common thing. For instance, like again, a kilogram is the weight of a liter of water. Why do we use water? Why didn't we use something like oil or lead or mercury? Well, water is just a very common substance, so we just chose that. So one carbon-12 atom weighs about 12 AMUs. That's our definition of what atomic mass unit is. On that same scale, a hydrogen 1 atom weighs 1.008 AMUs, and an oxygen 16 atom weighs 16 AMUs. It's approximately what the mass number is. Okay, so hydrogen 1, it's not exactly 1.000, but it's, it's around 1. Oxygen 16 weighs around 16. So the definition of a AMU, well, 1 AMU, technically, 12 AMUs is the weight of 1 carbon-12 atom. Okay, so we're going to use that scale. Knowing that scale, I'm going to actually get back to that later. So let's talk about now lithium. Lithium is made up of, in natural form, lithium-6 and lithium-7. In nature, if you had a chunk of lithium is either the lithium-6 form or the lithium-7 form. There is no lithium-8, there is no lithium-5 in nature. When you saw the lab on atoms, if you had a lithium-5, that nuclei is very unstable. It wouldn't last. It would not. Nature doesn't make that. Same with lithium-8. So in nature, lithium forms as lithium-6 or lithium-7. And here are the natural abundances of each one. 7.42% of lithium in nature is lithium-6, and 92.58% of lithium in nature is lithium-7. Lithium-6 has a weight of approximately 6.015 AMUs, and lithium-7 has a weight of 7.016 AMUs. Okay, so if we're talking about the weight of an average lithium atom, well, lithium is either going to be lithium-6 or 7. And lithium-6 weighs about 6, and lithium-7 weighs about 7. You'd probably say, oh, well, the weight of the average one will be around 6.5. Well, not exactly. Notice there's 92% of them are lithium-7, and only 7% of them are lithium-6. The average weight will be closer to 7 than it will be 6, because you have just a lot more of them that weighs lithium-7, or weigh 7 than 6. In fact, if you had 100 atoms, 7.42 of them would weigh 6, and 92.58 of them would weigh 7. So, thinking about that, if you had 100 atoms, 7.42 of them would weigh 6.015, and 92.58 of them would weigh 7.016. On a calculator, that comes out to be 6.941. The average lithium atom weighs 6.941 AMUs. That is actually, this is for lithium, but we did this with every single atom on the periodic table, knowing their relative abundance in nature, knowing the weight of each of the isotopes. We did the same calculation for every single atom, and here it is. Let me move my face. Put it down here. Okay, so lithium has an average weight of 6.941. Lithium average weight is 6.941. That's what that is. An average lithium atom weighs 6.941 AMUs. The rest are all on here as well. An average carbon atom weighs 12.01 AMUs. An average oxygen atom weighs 16.00 AMUs. Average sulfur atom weighs 32.07 AMUs. The average chromium atom weighs about 52.00 AMUs. Notice this is just the 4 sig figs on this periodic table. They actually go on beyond this. Oxygen's really more like 15.9994, but this is just the 4 sig figs. So now that we know this, we can now compare weights of atoms. Notice sulfur weighing 32.07, oxygen weighing 16. An average sulfur atom is about double that of oxygen. Not exactly double, but about double. What else do we see here? I could see that a carbon atom, 12.01. Well, that's not exactly double lithium, but 6.941 compared to 12, a little less than double the weight. Well, or you could say nitrogen, 14.01, is about double the weight of a lithium atom, at least an average one. These are averages. There's no actual atom. There is no carbon atom that actually weighs 12.01. It's kind of like saying, hey, my average class size, which I'm making up right now, is 32.3. I don't actually have any classes with 32.3 students because obviously there's no such thing as 0.3 students. So because of that, these numbers are about the average one. No actual atom actually has this. The reason why we only care about the average when we're talking about large quantities of atoms, I'm not even talking about millions or billions and trillions. Those are small numbers. When we're talking about numbers of atoms, we're talking about billions of trillions of a lot of atoms. So when we talk about large numbers like that, we only actually care about the average one and not any individual one. That's why we use these numbers. Okay, I'm going to get to an important concept or term. Let me move my face in the middle here. Okay, so you probably already know what a dozen is. A dozen is 12. If you bought a dozen eggs, you have 12 eggs. If you bought a dozen pens, you have 12 pens. If you bought a dozen calculators, you have 12 calculators. If you have a dozen pairs of glasses, you have 12 pairs of glasses. So a dozen just means 12. You have a dozen cupcakes, you have 12 cupcakes. And let's not get into baker's dozen or anything weird like that. So a dozen is 12. A pair is 2. A pair of shoes, you have 2 shoes. You have a pair of socks, you have 2 socks. A pair of people, we're talking about 2 people. A pair is 2, a dozen is 12. Well, there's a term that is similar to this concept in chemistry, and it's called a mole. A mole, M-O-L-E, or M-O-L for short, we write either one, it's the same, is an amount of substance that contains as many elementary entities as there are atoms in exactly 12 grams of carbon-12. So, how many atoms are in exactly 12 grams of carbon-12? That is the definition of a mole. How many atoms are there in exactly 12 grams of carbon-12? Way back when, I don't know, it's a long time ago, you'll watch an Edpuzzle thing on this later, but this guy named Lorenzo Avogadro figured it out. How many atoms there are in exactly 12 grams of carbon-12. I don't know how he did it, but he did. And what he found out was there are, in 1 mole, 6.0221367 times 10 to the 23rd atoms in 12 grams of carbon-12. Again, I don't know how he figured it out, but he did. That number, N for number, A for his name, is called Avogadro's number. Avogadro, Lorenzo Avogadro, in, I don't know what, long time ago. I don't know what, it's not recent, like 16th, 17th century, long time ago. He figured out 1 mole is 6.022 times 10 to the 23rd. Oh, and we'll just, 4 sig figs is good enough. 6.022 times 10 to the 23rd. If you feel like using, what is this, 4, 5, 6, 7. If you feel like using 8 sig figs, go for it. But that's kind of like going overboard. Like 3.14 is probably good enough for pi in general. But if you want to use 3.141596, I don't know digits beyond that, go for it. Okay, so 6.022 times 10 to the 23rd is good enough for us, 4 sig figs. That number is called Avogadro's number. 1 mole is 6.022 times 10 to the 23rd. And that is kind of like what I said, a dozen is 12, a pair is 2, a mole is 6.022 times 10 to the 23rd. If you have a dozen eggs, you have 12 eggs. If you have a pair of eggs, you have 2 eggs. If you have a mole of eggs, you have 6.022 times 10 to the 23rd eggs. If you have a dozen pens, you have 12 pens. If you have a pair of pens, you have 2 pens. If I have a mole of pens, I have 6.022 times 10 to the 23rd pens. If you have 12 atoms, you have a dozen atoms. If you have 2 atoms, you have a pair of atoms. If you have a mole of atoms, you have 6.022 times 10 to the 23rd atoms. So a mole is a number, that number being 6.022 times 10 to the 23rd of anything. Okay, so that number are called Avogadro's number. Okay, so next thing, I'll move my face again. Something called molar mass. How much does 1 mole of something weigh in grams? Okay, Now, if, actually, I want to go back to a dozen. A dozen is 12. If someone asks you, how much does a dozen weigh? You're like, wait, a dozen what? You can't say how much does a dozen weigh. A dozen is 12 things, but how much does a dozen weigh makes no sense, because we know a dozen eggs does not weigh the same as a dozen atoms, which does not weigh the same as a dozen cars. Well, molar mass is the same thing. How much does a mole of what weigh? A mole of eggs, a mole of shoes, a mole of marbles, or a mole of atoms? But molar mass is how much does 1 mole of whatever weigh in grams. That's the definition of molar mass. How much does 6.022 times 10 to the 23rd of that whatever it is weigh in grams? If you had 6.022 times 10 to the 23rd of them. Okay, so a few things. So we said 1 mole of carbon 12 atoms is 6.022 times 10 to the 23rd atoms. And we also defined that as equaling 12 grams. We also noted that in when we defined what an AMU was, 1 carbon 12 atom weighs 12 AMUs. That means on that same scale then, 1 mole of carbon 12 atoms weighs 12 grams. So 1 carbon 12 atom weighs 12 grams. In other words, if 1 carbon 12 atom weighs 12 grams, 1 mole of lithium atom weighs 6.0941 grams. Or 1 mole of anything on a periodic table, that number is also the molar mass in grams. What? Let me go back to that periodic table that we saw earlier. Oops, right here. Let me move my face again. These numbers are AMUs. 1 lithium atom weighs 6.941 AMUs. But if you had a mole of lithium atoms, it weighs 6.941 grams. 1 mole of carbon atoms weighs 12.01 grams. 1 phosphorus atom weighs 30.97 AMUs. But a mole of them weighs 30.97 grams. 1 oxygen atom weighs 16 AMUs. 1 mole of it weighs 16 grams. 1 bromine atom weighs 79.90 AMUs. 1 mole of it weighs 79.90 grams. So these numbers, if you just talk about a single atom of them, it weighs that in AMUs. But once you have a mole of them, that is the same thing in grams. The atomic mass is its molar mass. 1 atom might weigh 12.01 AMUs. Its molar mass would be 12.01 grams. Okay, so here's a picture of carbon, sulfur, mercury, copper, and iron, at least a mole of it. So how many atoms are in that picture of carbon right here? You're right, 6.022 times 10 to the 23rd. That's a definition of a mole. How many atoms are in this right here? This is 1 mole of iron atoms. How many atoms are there here? You're right, also 6.022 times 10 to the 23rd. What about here? How many atoms are in 1 mole of sulfur? This is a picture of 1 mole of sulfur. You're right. That's also 6.022 times 10 to the 23rd. In fact, they're all 6.022 times 10 to the 23rd. This is 6.022 times 10 to 6.022 times 10 to the 23rd mercury atoms. This is 6.022 times 10 to the 23rd copper atoms. So they have equal number of atoms. What they don't have equal is the weight. What does 1 mole of carbon atom weighs and sulfur atom? Carbon, sulfur, mercury. Let me just do those three first. How much is 1 mole carbon? How much is 1 mole sulfur? How much does 1 mole mercury atoms weigh? I don't know. Actually, I do kind of know offhand, but for most people, we'll have to look on a periodic table. Let me go back. Here it is. So it's copper, sulfur, and mercury. A copper atom, where is copper? Right here. 1 mole of copper atom weighs 63.55 grams. Another thing that was on there was carbon and sulfur. Carbon is right here. 1 mole of carbon atom weighs 12.01 grams. Sulfur right here on the periodic table. 1 mole of sulfur weighs 32.07 grams. And I think also on that thing, there was also mercury, and I forget what else was in that picture. But mercury was 200.6 grams, 1 mole of it. We had iron, mercury. Yeah, no, that was mercury, 200.6. Forget what the last picture was. Let me look. Oops. Oh, iron. Iron, I think, was 54 point something. Let me look. Iron, 55.85. 1 mole of iron atom weighs 55.85 grams. Okay, so how much does 1 mole of anything weigh? It's on the periodic table for any element. So you will need to use a periodic table or have a periodic table available for this chapter. You don't memorize these kind of numbers. I mean, you can have a blast, okay? You don't need to memorize these numbers. They are on a periodic table. You just need to reference this atomic mass in atomic mass units, but again, atomic mass units is the same as molar mass. Atomic mass is the same as molar mass. So, oops, I passed it. So this is a carbon, or a 1 mole carbon. There's 6.022 times 10 to the 23rd atoms in here. And on a periodic table, this would weigh 12.01 grams. Okay. I'm going to just actually skip this one for right now. So, do we understand molar mass? If we do, we can answer this kind of question. And the question says, well, how many atoms are in 0.551 grams of potassium? You're like, I don't know. I don't know how to do this. Well, this goes back to, I actually asked 2 questions first. First question, how many atoms are in a mole of potassium atoms? If you had a mole of potassium atoms, how many atoms are there? So that's the first question. Second question, if you had a mole of potassium atoms, how much would that weigh? Okay, well, you probably already know the weight of 1 mole of potassium atoms. I have to look on a periodic table. And I'm not going to flip back to the periodic table, but if you looked at potassium, it would weigh 39.10 grams. That's from the periodic table, okay? Not something you would memorize. You would always be given a periodic table in regular class. So 39.1 grams. And the second question I asked was, how many atoms are in 1 mole of potassium? You're right, 6.022 times 10 to the 23rd atoms. So notice how I wrote them. Something equaling something, something equaling something, like 1 inch equaling 2.54 centimeters, or 1 kilometer equaling 1,000 meters. These are conversion factors, things that equal. I'm going to use these 2 conversion factors to change my grams of potassium given, into number atoms. And the first one I'm going to do is this one here. Change grams into moles. Notice I'm given grams, and that's right here, 0.551 grams. I'm given grams. I want to change grams to moles. Multiply this by the conversion factor. I put grams on the bottom. 39 grams is 1 mole of potassium. The next conversion factor I'm going to use is the second one. I'm going to change my moles into number atoms. Because why? I currently have moles of potassium. I'm going to multiply by conversion factor, or moles of potassium on the bottom, atoms of potassium on the top. And notice grams of potassium cancel. Moles of potassium cancel. And now I have left our atoms of potassium. It will be 0.551 divided by 39.1 times 6.022 times 10 to the 23rd. On a calculator, I got 8.49 times 10 to the 21 atoms, 3 sig figs. So if you had 0.551 grams of potassium, in it would be 8.49 times 10 to the 21 atoms of potassium. This, you have to use the periodic table to look up the molar mass of potassium, But this is now really useful because we can now figure out how many atoms there are in exactly, say, if you had a penny that weighed 2.5 grams and it was pure copper. Now you can figure out exactly how many atoms are in a penny. You didn't count it, you don't need to count it, but you can calculate how many atoms there are in, say, a penny, as long as you know the weight in grams. Or if it's some other units, you just convert it to grams. Okay, just a little bit more. I think 2 more slides for now. Molecular mass or molecular weight, they're the same thing. Okay, molecular mass or molecular weight. Molecular mass, I don't want to get rid of that. Oh, molecular mass or molecular weight is the sum of the atomic masses in AMUs of a molecule. For sulfur dioxide, well, if you looked up sulfur in a periodic table, sulfur in a periodic table is 32.07 AMUs. And oxygen on a periodic table is 16 AMUs. But a sulfur dioxide molecule is 2 oxygens in it. So if you added 1 sulfur, 2 oxygen, that adds up to be 64.07 AMUs. 1 sulfur dioxide molecule weighs 64.07 AMUs. But like atoms, the molecular mass and molar mass are the same thing. 1 molecule weighs 64.07 AMUs, but if you had 1 mole being 6.022 times 10 to the 23rd of them, if you had 6.022 times 10 to the 23rd sulfur dioxide molecules, it would weigh 64.07 grams. 1 molecule weighs 64.07 AMUs. 1 mole of it weighs 64.07 grams. So a mole of the stuff weighs whatever it is in grams. 1 molecule of it weighs whatever that number is in AMUs. So, do we understand about molecular mass? Hopefully we do. Question here, how many hydrogen atoms are in 72.5 grams of C3H8O? Okay, so first of all, let's find the molar mass of the whole thing. The molar mass, this is 3 carbons. Okay, this is just to the nearest whole number, but carbon on a periodic table, 12.01. 8 hydrogens. Hydrogen on a periodic table, 1.008. Oxygen on a periodic table, 15.9994. Okay, this is just rounded just for a nice number's sake. So, 1 mole of the thing weighs 60 grams. 1 mole of the thing weighs 60 grams, but 1 molecule of this thing also has 8 hydrogen atoms. Also has 3 carbon and 1 oxygen, but I only care about the hydrogen because the question is how many hydrogen atoms. 1 molecule of C3H8O is 8 hydrogen atoms. Notice I have 2 conversion factors now. 1 mole of it is to grams, and once I know how moles of the stuff, I can change it to molecules, and if I have molecules, I can change it to number of atoms. Okay. Because I know 1 mole of anything is 6.022 times 10 to the 23rd atoms. So I'm going to start with the given, 72.5 grams. I'm going to change my grams to moles. Here, 60 grams, I'm going to put that in the denominator, is 1 mole of this stuff. Then I'll have moles of C3H8O. Once I have that, I can change the number of hydrogen atoms. 1 mole of C3H8O is 8 moles of hydrogen atoms. And once I know that, I know 1 mole of hydrogen atoms weighs 6.022 times 10 to the 23rd hydrogen atoms. That cancels, moles of hydrogen atoms cancel. So the only thing left are hydrogen atoms, or 5.82 times 10 to the 24 hydrogen atoms. Okay, so that is a bit of molecular mass. We'll be doing more of these. I know this is the first time you're seeing it, but it's quite a bit, but we'll be doing more of this stuff. But this is what molar mass and molecular mass and moles are all about.